I've been building Android apps for over a decade, and I can count on one hand the moments where I felt the platform shift under me, not new APIs, not new design guidelines. The actual model of what Android is, how apps fit into it. This is one of those moments. At Google I/O 2026, they announced AppFunctions, Agentic Android, and Gemini Nano 4. If you read the developer blog, you know the feature names. What I want to talk about is what they mean for how you write code and how fast you need to move. Before I get into what Google shipped, I need to tell you something that came from OpenAI. They published a case study, Sora for Android, a full production app, was built in 28 days using Codex, their AI coding agent. 28 days. Production app. I'm not saying this to hype AI tools. I'm saying it because it changes the competitive landscape you're in. The barrier to shipping an Android app is dropping fast. The developers who win in that environment are not the ones who know how to write a retrofit interface. They're the ones who understand where the platform is going, who know what app functions are, why on-device inference matters now, how to design for agentic invocation. That knowledge is rare right now. You have a window. Here's how AI works in most Android apps right now. User taps a button. Your app calls a REST endpoint. A model in the cloud processes it. You get JSON back. You display it. The AI part is a network call. Your app has no intelligence. It's a thin client for someone else's model. That works fine until it doesn't. No network. Latency spikes. User data leaving the device. Inference costs at scale for privacy-sensitive apps, for offline-first apps, for anything where 400 milliseconds feels slow. This model has real limits. Google has been working on fixing this for years. At I/O 2026, they shipped real answers, not previews, actual APIs. I want to start here, not with app functions, because Nano 4 is what makes the rest of this credible. On-device AI on Android has been a promise for a few years. Gemini Nano 3 existed. ML-Kit existed. But in practice, the models were too slow. The battery drain was too high, and language support was so limited that for most of us building for users in Europe, in Ukraine, in Poland, in markets outside English-speaking countries, on-device inference wasn't actually shippable. Nano 4 changes three things specifically. Inference speed is meaningfully faster, the difference between sluggish and interactive. Energy consumption dropped significantly. Battery was the reason most of us stayed away. And Ukrainian, Polish, and dozens of other European languages now work on device. If you're building for a European audience, this is not a minor footnote. Quick question. Have you actually tried running Gemini Nano in a production build, or does it still feel too early? Drop it in the comments. And if you want the hands-on Nano 4 implementation video, subscribe now. That video is coming. Now that you understand why on-device inference is real, app functions make sense. If you've used AI tools lately, you know MCP Model Context Protocol. It's how AI agents communicate with external tools. Claude Code uses it. OpenAI uses it. It's become the standard for AI-to-tool communication. Google built their own version of this directly into Android. They're calling it AppFunctions. The idea: your app declares a set of capabilities in a structured, machine-readable format. The system's intelligence layer, Gemini Android agents, discovers those capabilities and invokes them directly. Say your app is a calendar. With AppFunctions, you expose a create event capability. The assistant calls it, no UI required, your code runs, the event gets created. This is a new class of entry point for your application. Not an intent, not a deep link. A capability that agents discover and invoke directly. In June 2026, very few apps implement this yet, so this isn't a fix it this week or you're broken situation. But the earlier you add app functions, the less architectural rework you face in 12 months when agents are mainstream. App functions are the interface. Agentic Android is the consequence. An agent doesn't just call code, it makes decisions, plans multi-step actions, calls your app functions as part of a larger workflow it's orchestrating. Your app becomes a tool in someone else's plan. The architecture implication is the part most developers miss. Your app today assumes a human is driving. Error states show a snack bar or shows a dialogue. State is reflected in UI components. None of that works when there's no user present. When an agent calls your create calendar event app function at 3 a.m. as part of an automated scheduling workflow, your app functions need to be idempotent. Calling them twice with the same parameters should not create two events. Your error states need to be machine readable, not a string for a snack bar, but a typed error code the agent can act on. Your authentication flows need pre-authorized tokens. You cannot pop a login dialog at an agent. This is not a small change. It's a different mental model for what your app is. Let me make this concrete with a real example. Take a note-taking app. Today, user opens app, types note, taps save, view model calls repository data written. Tomorrow, agent calls create note app function, repository called data written, no view model, no UI, same repository, different entry point. That's actually good news. If you've separated your data layer from your UI layer, if your repository doesn't know what the view model is, you're most of the way there. What changes? Your repository can now do local inference using Nano 4, not just fetch and cache, but fetch and classify. A node that auto-tags itself on write. Your use cases need to handle probabilistic outputs. AI doesn't return a node category enum. It returns, this is probably work, confidence 0.87. And your app functions module needs integration tests that verify correct behavior when invoked without a user, not UI tests, headless integration tests. If your architecture is already clean, this is incremental. If your models are calling the database directly, you have bigger problems than app functions. Here's what I'd actually do this month. 1. Read the App Functions developer docs and identify one feature in your current app that could be an app function. Just one. You don't have to ship it yet. The value is in the thinking. What does your app do that an agent should be able to call? 2. Try the Gemini Nano 4 APIs on a device that supports them, not a demo app. Take something real from your codebase and see if you can run inference on it locally. The experience gap between reading about it and running it is significant. 3. Look at your app functions adjacent code and ask whether it would work if called with no UI. If the answer is it would show a dialog, that's your first refactoring target. The next video on this channel is going to be the app functions deep dive I couldn't fit here. Actual code, actual developer experience. What works today, what's still rough, and the architecture patterns that make it fit cleanly into a production app. If on that when it drops, subscribe. If you've already started with any of this Nano 4, app functions, agentic workflows, drop a comment. I read them, and what you're running into shapes what I cover next. Links to everything referenced are in the description. See you in the next one.